Why is that one camera?
Yeah, that's all.
Hey, boys and girls, let us begin.
$200 cheaper.
Are we done?
Yes.
Ready to move forward?
Yes.
All right. The reason Avocado's number is Avocado's number is this guy named Amadeo Avogadro. He investigated gases. So his law allows us to use the ideal, basically treat all gases as ideal and use a couple of things. He basically says if we're going to treat gases as ideal, then 1 mole of a gas behaves exactly like 1 mole of any other gas if they treat it as ideal. And what that means is a mole of helium, molar mass 4, will occupy the same volume and pressure as a mole of krypton, molar mass 84. So his law is the reason why we can basically say, we're going to treat this gas like ideal. It's 6 times 10 to the 23rd molecules of any gas will behave like 6 times 10 to the 23rd molecules of any other gas. Now that's not the principle we're talking about today. The principle we're talking about today is Boyle's law. And if you watch the video on Boyle's law, it works like this. Volume and pressure are related in a very particular way. So this is a machine that we use in physics, kind of neat, and it allows us to measure volume, temperature, and pressure. So what I'm going to do is I'm going to open this valve, or open the syringe, increase the volume, and right now the pressure value is measuring the atmospheric pressure, approximately 1. I don't know why it doesn't give you, it's measured in hectopascals, which is just weird. Basically hundreds of pascals. Okay, so I'm going to close this. So now the valve is closed. When I reduce the volume, look what happens to the pressure.
Increases. It's going up. It's going to pop.
No. I know, right? I actually broke one of these at an AP workshop because I was like, I want to stretch it to the limit, and it broke. So what happened to the pressure?
It went up.
It went up, right? So there is a relationship between pressure and volume of a gas. If volume goes down, pressure goes up. And then we can just open it up. There we go. Are we back to 1?
Yes.
Okay. Now I'm going to take the volume and I'm going to increase the volume.
It's a vacuum.
Your country? My friend said that you had a big. You're in the way.
Julian obviously
It's not in my way.
You can stand up. Okay, so I increased the volume and the pressure went down. So that is called an inverse relationship. And it has the formula of this. The pressure and volume, the product of pressure and volume, is a constant. Which means if our pressure goes up, our volume goes down. Or if our volume goes up, our pressure goes down.
Crazy.
It's called an inverse relationship. And it has this formula. Y is equivalent to 1 over x. Equivalent means we're not going to worry about this.
What is it?
Y is equivalent to 1 over x. In other words, y times x is a constant.
Yeah.
So you do,
That.
in case you're math, you do that when you don't know what the slope is, or you don't care what the slope is.
So it's not y equals 1 over x?
Correct. If it was y equals 1 over x, then the slope would have to be 1. If you don't know what the slope is, or don't care what the slope is, then you use equivalent. So that's the important thing. If temperature is held constant, volume varies inversely with pressure, and it has these two formulas. PV equals a constant.
Wait, what's K?
Constant. Some constant we don't care about. Because in this class, the best way to do Boyle's law is to say the pressure and volume in one circumstance equals the pressure and volume in another circumstance. Which means if our volume increases, if V2 is larger, then P2 better be smaller. And it's not going to come up in this class, but if it ever comes up in the future, the units have to be the same. They have to be atmospheres, or pascals, or millimeter mercury, and volume has to be liter, or milliliter. The units have to be the same. So if you ever get a situation where the units aren't the same, you have to make them the same. The volume will do that. We're going to use atmospheres across the board, but sometimes you're going to get an exercise that's like, the volume at 300 milliliters, what's the volume at 2 liters? So either make the 300 0.3 or make the 2 liters 2,000. Huh? Guess we're going to return these back to the other side of the room. So we just finished the lens of the mirrors and the lenses.
I don't know. Do you know what mirror objects? What? That's not.
Okay. So, any questions about this stuff? If you're ready to do some practice, give me a thumbs up. Let's do some practice.
Yes.
Okay. A bicycle tire has a volume of 8.28 liters at 4.13 atmospheres, which is pretty typical for a bicycle tire. What is the volume if the pressure is increased to 6.61 atmospheres? So again, the best way to do these is just say P1, V1 equals P2, V2. And the pressure, they are the same units. So we're going to start with 4.13 atmospheres multiplied by the initial volume of 8.28 liters. And that's going to equal the pressure of 6.61 atmospheres times V2. So if you have a calculator, bang on your calculator and see what the new volume is.
5.17.
Can I get a second on that?
Wait, so
Keep asking me calculator.
I got 34.
Process.
There's a booger on the back of that.
Ew.
5.17.
5 point, you said 8.7? 1.7. Okay. So that sounds good. 5.17, and the unit is the liter. So that's really all it is. It's just, if you only have pressure and volume and temperature is the same, then you just make sure the units are the same and solve for x.
Wait, what is it equal? 5.17.
I want to make sure I'm not missing something important.
I got it right.
Okay. The only real wrinkle in this is reading the question. Let me give you an idea. Let me give you an example. An empty flask with a volume of 480 milliliters at 1.1 atmospheres is corked and half filled with water. What will be the pressure of the air above the water? If it's half filled with water, what is the new volume the gas can expand to? 240 milliliters.
Crazy.
Is that clear?
It's like half of 480.
Yeah, but you'd be surprised how often people like double it. They're like, oh, half. So the volume is now 960? You put water in, the volume of gas shrinks. Okay, if you have questions, now would be a good time to ask. If you're ready to work on your own, give me a thumbs up. Off you go.
Once we're done with our stuff, can we go and
Yes.
boom boom fire?
Once you have all of your activities done, you can go boom boom.